Okay, there's a couple of questions on here that weren't on the tests last semester, so I didn't have any videos for. So I'm going to do them now, okay? Here's an extra video just for certain pieces that will be in the test that I didn't have originally. Okay, now, it's to do from 7.7, so these imaginary ones again, okay? So look at this. Now, we're looking to, well, let's have a look at what the previous question was. Okay, that is straightforward multiplication, but involves the letter I. Now, 41 and 42 look like they're divisions, all right? But you can't actually divide those, so what we do is we rationalize the denominator, just like we did it with square roots. Remember this? So a quick one, remember, if I have, say, something like 5 over root 3, I would multiply by another root 3, but don't forget to do the same to the top, okay? So I would have, on the top, 5 root 3, but importantly, on the bottom, root 3 times root 3 is just a 3, okay? Remember, you can't do anything with these 3's. One's inside a square root, no reducing. 5 root 3 over 3 is the answer. Okay, so that's that. That's just me rationalizing with square roots. How about rationalizing with the letter I? So the point is, how do I turn an I into a real number? Okay, well, think about it. An I squared is a -1. There you go, I have a real number. Okay, so I need to make, or put another I, okay, whatever I do to the bottom, do to the top. Now look, so what I have on the denominator is 4I squared. But remember what I squared is? It's -1. So what's 4 times -1? That will give me -4 on the denominator. Again, remember, this bit here is -1. I've still got to do this on the top. So that is 5I. Okay? So that's basically the answer. I could write it a bit better by putting the negative just kind of in the middle. So -5I over 4. Okay? It's a minus. Okay? So remember what happened there? The 4 became a -4 because of the I squared. Right, that's with a single term on the denominator, 4I. How about question 42, where I've got two of them? Remember, with square roots, we had to use the conjugate. Actually, there's a bit of that up there. Okay, so what's the conjugate of 3 plus 2I? It's 3 minus 2I. Okay, 3 minus 2I. Whatever I do to the bottom, I've got to do to the top. Okay, there we go. Now, again, the reason why we use the conjugate is because it will turn it into a nice real number. Okay, without anything else, no i's, no roots, no x's. Right? Okay, let's have a look at this. Okay, what's 3 times 3? That's, I'll do it below 9. Now remember, when you're dealing with conjugates, you don't have to do the full FOIL. It is a FOIL, okay? But really, you only do the first and the last, because the oi bit, the outer and the inner, will cancel. But I'll show you, okay? So 9 is the first. Look at this. The outer would be -6I, okay? The inner would be +6I. There you go, I'm just wasting my time because they will cancel, okay? Let's do it, okay? So that's going to go with that. They've gone. And the last, here's the important thing about the last is, right now it looks like 2I times -2I would be -4I squared. But remember what squared, okay? Remember what this is? That's a -1 with the -4. This will change it to a +4. Okay, -4I squared is +4. So here we go. All I have is 9 and 4. The denominator is 13. Now really, all you really have to do for the shortcut is look. 3 times 3 is 9, right? The last is 2 times -2, which would be -4, but I squared makes it +4. You're always adding the number, okay? So 9 and 4 is 13. There's my denominator. And what's on the top? Distributive law. 9 times 3 is 27. 9 times -2I, -18I. And that, folks, is the answer. 27 minus 18I over 13. Okay? And that's it. That's just using the conjugate. Okay?